Hello my friends, welcome to my channel and I hope you're all fine. I'm very happy and very excited because a few days ago I've just invented a new battery, a new type of battery. So in today's video I'm gonna tell you how you can make this battery step by step. I will tell you each detail, so after watching this video you will be able to make your own battery. Before we get started to video, I will give you some information about the batteries, but I have a request from you. Please don't use the information in this video for the commercial purposes. After you watching this video you can make your own battery, but please don't use these informations for commercial batteries because the patent process is continue for this battery, and I want to tell you I will share the information with you, but I believe you that you will not use this information for commercial purposes. Okay my friends, let me give you some information about this new battery. The operating voltage of this battery is 1.6 volt and the capacity is depending on the size of the battery, but if you make in this size, in the size of AA battery, the capacity will be 800 milliamp hours, so it's pretty good, pretty effective capacity for a battery, for a rechargeable battery. It is a rechargeable battery, by the way, and the most important point of this battery is it is 100% environmentally friendly. There is no poisoning compound or poisoning substances in this battery, and it is very easy, very easy to make, very easy to build. Everybody can build this battery. Okay my friends, let's start to make our battery. For our battery, first of all, we are going to prepare the active materials for our negative electrode and for our positive electrode. For the negative electrode, I am going to use iron oxide. For the negative electrode, I am going to use iron oxide. And for positive electrode, I am going to use copper oxide. It's also called as cupric oxide. This is black brown color copper oxide, one light brown copper oxide. I'm going to use this material to make my positive electrode. So first of all, let's prepare, let's make our negative electrode. For making our electrodes, I need 20 milliliters of deionized water in a glass, and I am just going to add some sodium silicate. For 20 milliliter of deionized water, only 2 milliliter of sodium silicate will be enough. I will just add some. Okay, that's enough. Now I am going to give a stir. 20 milliliter of deionized water and 2 milliliter of sodium silicate. And just give a stir. And now I'm going to use this material. This is waterproofing paint. I will put some waterproofing paint into the water because I need to make it some plasticide. If you don't put this material, your electrode will be very fragile and it will crack, it will break. So in order to make it a little bit more plasticized, I will put this material into the water and sodium silicate. Okay, not too much, about just half gram will be enough. Okay, and mix it again. Okay my friends, now I am going to add iron oxide into the water and sodium silicate, about 20 grams. I will add until it becomes a slurry form, my friends, okay? Just add iron oxide until it becomes slurry form. Okay, let's mix and see if it's enough. See my friends, it's still too much watery, so I will add some more. Okay, my friends, I think that's enough. Mixing process is very important. You have to mix the slurry, the active material very well. Now I'm going to use my small blender to mix it better, my friends. I'm going to mix it for about half an hour, my friends. Okay, my friends, after mixing for about half an hour, you will get this. This is our active material for our negative electrode. Now, you need to make the same thing to prepare your active material for the positive electrode. Okay, I've just made my positive electrode. Just do the same process, but instead of iron oxide, you are going to just add copper oxide, cupric oxide, instead of iron oxide. All the other process is the same. Now we have the active materials for our battery. This is iron oxide active material for our negative electrode, and this is the copper oxide active material for our positive electrode, my friends. As you see, for the positive electrode and for the negative electrode. Now it's time to make our electrode and our current collector. Okay, my friends, for the current collector of our electrodes, I'm going to use copper foil. The size of the copper foil is 25 centimeter long and 6 centimeter length. Now I will divide it into two pieces, but before do this, I need to clean my copper foil. For cleaning my copper foil, I'm going to use this mixing. It is some hydrogen peroxide and hydrochloric acid, mixing of them, and I will just clean my copper foil with this solution. Just a little bit on the tissue paper and just clean it. As you see, it will remove the oxidation layer on the copper foil. Just a little bit, not too much, and clean it. The other side. Now dry it. Okay, my friends, now I will divide the copper foil into two pieces, and please look at how I will divide it. It's very important to cut the copper foil just like this, because I need some terminal for the electrode. This part will be the terminal for my electrode. As you see, my friends, the size of the surface area of our current collector is 25 centimeters and 3 centimeters, so it is 75 centimeters square. Of course, this is a demonstration video. The size of our battery will be a little bit small, but if you want to make a bigger battery, you can use a larger copper foil. For example, not 75 centimeters square. Instead of 75 centimeters square, you can use 750 centimeters squares. It means 10 times bigger, larger than this battery, so the capacity will be increased, of course. But in today's video I'm just going to make a small battery, but the capacity will be sufficient for us, will be enough for demonstration purpose. Okay, now our current collectors are ready. Now we will apply the active material to our current collector. Okay, my friends, with the help of a brush, first of all I will apply the active material for the negative electrode, I mean the iron oxide. I will apply iron oxide to one copper foil. Okay. Try to apply evenly as much as possible. The layer should be about 50 microns, not too thick, not too thin. Okay. It could be a little bit thick, but not too much, because it's not a supercapacitor, it's a battery, so the amount of active material is important for us. Just apply. I'm going to apply these active materials on the both sides of the electrode. After it dry, I will just apply on the back side of the electrode, and the both sides of the electrode will be painted with the active material. And after that we will let it to dry for about 1 or 2 days. After it completely dry, we will continue to make our battery, my friends. Okay. Okay, my friends, now I am going to clean my brush and apply the active material for my positive electrode. Okay, now apply in the same way. Okay, my friends, I painted my electrodes. Now I will let them to dry, and after it dry I will paint the back side of the electrodes, and again wait until it dry. After they are completely dried, we will continue to make our battery. Okay, my friends, our electrodes are completely dried. Now we can continue to make our battery. This is the negative electrode and this is the positive electrode. Now I'm going to 2 pieces of separator, just like this. This is regular paper separator. This is regular paper. I'm going to use these 2 pieces of separator, a little bit longer and larger than the electrodes, and I will roll up my battery and put it in a case and fill it up with an electrolyte. Okay, now let's continue, my friends. First of all, I will put my negative electrode. I will stable my separator with a tape on the ground and put my negative electrode. The positioning is very important. Please watch very carefully. I'm going to use another tape to stable my electrodes also. Now put the other separator. They need to perfectly overlap with each other. To put my positive electrode a little bit further than the other one, just like this, a little bit further. And again, adjust everything. Also use a tape to stable this one. Use my tape, put it over here, and I will roll them. Be careful, my friend, while we are doing this process. Okay, my friends, rolled it very tightly as much as possible. Okay, my friends, that's fine. Now I'm going to use another tape to hold them all together. Everything should be very tight. Okay, that's great. You see, very small, good roll of battery. Now I'm just going to use another tape. Roll it very tightly. Another piece. Okay, my friend, we just roll up our battery. As you see it looks very nice, very beautiful, small battery. Now I will put this battery in this plastic tube, in this container. As you see, it just fit inside it very well. So our battery is almost ready. Now it's time to fill the electrolyte. By the way, this is the positive terminal and this is the negative terminal. I will just mark the positive terminal. My friends, this one is positive and this one is negative. Now I will put it in the plastic tube. Now it's time to fill it with electrolyte. As an electrolyte, I am going to use water-based 1 molar sodium hydroxide solution. This is very compatible with the materials in our battery, my friends. Just add it with the help of an injection very slowly. The battery should soak the electrolyte. Don't fill very fast, just add slowly and wait until the battery soaks the electrolyte. You see, it slowly soaked the electrolyte inside it. When it's soaked, add some more. Very slowly. Normally, when you add the electrolyte to your battery, you have to wait for about a few days because it takes a few days to soak the whole electrolyte completely. So, in order to your battery work with 100% efficiency, you have to wait for about a few days. But today I'm not waiting that much. I will just wait for about 1 hour, and after that I will test my battery and share the result with you. Add some more. And wait a little bit. Okay, my friends, waiting after about half an hour. Now it's time to test our battery. I will show you inside it. You see, it's not still soaked the whole electrolyte. Can you see that? Some parts of the battery is dry still. So it means that our battery will not work with 100% efficiency, but it will be fine for us to make some test on it. By the way, just a moment ago I said this is the positive terminal, but I need to correct it. This is the negative terminal and this is the positive terminal. So I was mistaken, and let me correct this misinformation. Now it's time to charge our battery. I'm going to charge my battery with 0.2 amp about 1 hour, and after 1 hour we'll test our battery, my friends. Okay, the positive electrode. Before charge the battery, my friend, let me show you the initial voltage of our battery before charge it, because I need to show you something. And before charge the battery, the voltage is about 0.14 volt, because the distinction of the material we used on the positive electrode and on the negative electrode, so it's very normal. It's indicate that this is a real battery. Now we will charge our battery, my friends. I will charge for about 1 hour my battery, and after that we will test it. Okay, my friend, when you first start to charge, I will show you something. You see the voltage will immediately goes up to 1 volt, because this is a battery in a supercapacitor. So it will slowly increase up to 2 volt. It will take about 1 hour to increase up to 2 volt. By the way, if your battery soak the whole electrolyte and work 100% efficiency, it would take about 2 or 3 hours to completely charge. But now as it is about 20% efficiency, it will take 1 hour. 1 hour will be enough to completely charge our battery. So after 1 hour we will test our battery, my friends. Okay, my friends, after completely charge our battery about an hour, now it's time to measure the voltage inside it. I have my multimeter here, and I will just measure the voltage. As you see, we have 1.6362. It's normal. Our battery is, the operating voltage of our battery is about 1.6 volt, but as I said, it's not working with 100% efficiency. After a few days it will work 100% efficiency. Now it's time to see the power of our battery. I will run my small blender with our battery and see the power of it. See, my friend, how fast it can run the blender. You see? Our battery is working very well. One more time. My friend, there's nothing else, only my D battery. As I said, this battery, after a few days, this battery will work better and better than this time. My friend, this is my another battery, the same battery. I've just made this battery a few days ago, and it is working with full capacity. So I want to show you the performance of this battery with full capacity. First of all, let's run this blender. Can you see its power? Okay, now let's run this DC motor with my battery, my friends. You see, just the battery, nothing else. It can run the DC motor very fast. With full capacity, this battery is working very well. See? Okay, my friends, we get the end of our video. I hope you enjoyed the video and you can make your own battery at home. And if you like the video, please subscribe my channel and like the video. Take care of yourself. See you in the next videos, my friend.